Live button. Oh, you're live. Good evening. Good evening. We are here live tonight. We're going to give you all a couple minutes to join. I am a little late. I spilt water on my computer and phone. You know, life happens. And I just want to be transparent here. But we are here and we are excited. And we have some problems submitted that we are going to work tonight. And if you have any problems, you can always drop it in the messages on the Instagram. If you're here on YouTube, on Facebook, we would love to hear from you and share it out with somebody. Tell somebody we're here and that you want them to come here too and share with us tonight. So I'm going to give you all a couple minutes and then I am going to jump right into our first problem. Alrighty. Work it out Wednesday. Work it out. You know, we should probably get us a cute little song for Work It Out Wednesday too. Kimberly, are we ready? Are we all set on Insta? All right. I'm going to kick us off with this first problem. Yes, a song would be nice. It would be so nice to have a song. I'm going to kick us off at 7:10 on the dot. So I'm going to give people a couple more minutes to join and we're going to get right in. Where is my phone? Okay. All righty. Oh, somebody on Instagram said it's a little difficult to see. Think I should go lower? Let's see. Tell me if y'all can see any better. It is a little cut off, but I am going to read it. And we are at our 7:10, 7:11 mark. So I'll get started. Is that a little better? Okay. So we're going to kick it off. We had a problem submitted. Hopefully, Miss Skylar is on tonight and watching somewhere. And if she joins later, then I will bring the problem back up because I want to make sure we absolutely, our people that submit get to see their problem in action for sure. So she has what is the equation in standard form of the line that passes through the point 6 minus 1 and is parallel to the line that is represented by 8x plus 3y equals 15. And I know, hi, thanks for joining us tonight, Skylar. All right, so I'm going to write that because I know you all can't see it. The negative 6, it's actually positive 6 comma negative 1 is the point that it passes through. So the first thing we want to make sure we understand is this is parallel. And why is this important? If two lines are parallel, and I'm going to just draw us some parallel lines, or they could even look like this. Parallel lines will always have the same slope. So we want to remember that. Parallel lines have the same slope. All right? And I know I'm stuffing stuff here, but we're going to get there. So our problem is 8x plus 3y equals 15 is what we know. And so it's in standard form. So when we're in standard form, we don't know what our slope is, because what gives us our slope is when we have it in y equals mx plus b. So that's the first step. We need to change that standard form to y equals mx plus b. So we are going to do our 8x plus 3y equals 15 here. And let's get that x to be moved over. So we will get 3y is equal to negative 8x plus 15. All right. I'm taking you back. I'm taking myself back, okay? Let me tell you tonight, we all going back. All right. So now we're still shooting to get into this y equals mx plus b. And right, there's no coefficient in front of y. So we must divide by 3. And what we do to one side, we do to the other side. You absolutely can plug in the points, but first we want to get that slope and our y equals mx plus b here, so that then we can solve for our equation, okay? So now we end up with y equals negative 8x over 3 plus 5 as the equation, as the equation of the line that's parallel to the line that passes through that point, okay? So I want to make sure everybody understands that part. So now we need to come back and we need to actually use this point to find it. Does anybody know what equation we're going to use now that we have the slope here and we're looking for that other line? What could we do? Somebody said we could plug it in. We could also use, I just want to see if anybody has an alternative, because Kimberly might know what I like to use. But I'm not even going to get that complicated tonight. I'm going to keep it simple, because that's what y'all like, simple. Okay, so now that we know that slope is negative 8x over 3x, we're going to make our own y equals negative 8x over 3 plus b. Okay? You can absolutely use the point slope formula. All right, so because our slopes are the same, now we're going to take that 6 and negative 1, and we're going to plug those in for our x and our y so that we get our b. And then from there, we are going to get it back in standard form, but one thing at a time. So we're going to take our 6, 1. We know the 6 is our x and the negative 1 is our y. So I'm going to make it negative 1 is equal to negative 8 times 6 over 3 plus b. And we are going to solve. Get gritty with it, okay? All right, so we have negative 8 times 6, which gives us a negative 48 over 3 plus b equals negative 1. And so can we reduce that negative 48 over 3? We absolutely can. 3 goes into 4 one time, and then we'll have 18, so we get a negative 16 plus b minus 1. And let me lift it up so you all can see it. And we have our equal sign. And so we want to solve for b, so we need to get b by itself. So we're going to add 16 to both sides here. And so we will get 15 as our b. So 15 will equal b. And now our second to last step. Now we know, and let me find some space to write it. I'm all over the place. We're going to go from our equation here. Y is equal to negative 8x over 3 plus 15. So that is the equation that is parallel with the initial line in the problem. However, the problem says we want it in standard form. And if you notice our answers, they're in standard form. They're not in y equals mx plus b. So now we basically are working backwards to get to that standard form. And what do you notice is different? Well, one, that 3 is in front of our y. Yes, so we're going to multiply both sides by the 3. So we will get, and I just wrote way too big, y'all. Just excuse all of that. And what you do to one side, you will do to the other. So we'll get negative 8x plus 45 here. And then as you notice, because we want it in ax plus by equals c form, we need to add this 8x back to the other side. And so our final answer will be 8x plus 3y is equal to 45. And that is answer C. And I know that was a lot of steps, so I'm really going to repeat the meat and potatoes. So the meat and potatoes was, since they gave us the initial equation in standard form, we needed to change it to slope form so we knew our slope for our new equation. And for parallel lines, they must have the same slope. So our new equation had negative 8x minus 3 as the slope. And since we wanted to find what that equation was, we then used the point and plugged it into our point slope equation here. And we worked it out to get our b. And once we had that b, we created our equation. But then we needed to bring it back in standard form. I know that's a lot. That is. But what if there is a perpendicular line? I love that question. And I have an answer for you tonight. But first, let me see, because I know Skylar is watching out there. Skylar, did this make sense? And we are also going to work another one because I really want to make sure we knock this out of the park and we truly understand. I'm going to wait to hear from you in the chat, Skylar, if you're still with us tonight. It made more sense. Glad to hear. So guess what? Guess what, Skylar? You're going to help me walk through the next one because I want to make sure that you truly understand. Okay? So let's see here. I feel like I want to pick this fraction because I feel like we avoid fractions like the plague out here. Everybody's intimidated by them. But then again, I kind of want to start off with the standard form. So let's do number 2. Let's do number 2. And I'm going to call you all out to help me in the chat, okay? So it's the same concept that we just did. We have a parallel line, and so that is in standard form, which is this x plus 3y equals 3. And it always doesn't have to be in standard form, but it can be. And we know that parallel lines have the same what? Drop it in the chat for me, because this is the most important part here. It has the same what? Slope. Perfect. Ding, 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 ding. So first we want to get what is that slope for x plus 3y equals 3. So we want to isolate. So we're going to subtract our x by both sides. And we're going to get 3y is equal to negative x plus 3. And we're going to divide by 3 on both sides. So we're going to get y is equal to negative x over 3 plus 1. And we always remember, anytime we have a negative in front of that x, there really is an imaginary 1. So that slope is really a negative 1/3 x. Okay? So now we already know our slope. So we can make another equation off to the side here. y is equal to negative x over 3 plus b. And now we're going to plug in this negative 3 and negative 1. And I always like to label, so I make sure I put them in the right spots. That's my x, and that's my y. So my y is negative 1 is equal to my x, which is a negative 3. And since we're going to have a negative and a negative, what does that turn into when we put a negative by a negative? Anyone want to drop it in the chat? All right, well, positive. Thank you. Thank you. So we'll have that negative 3 here. So it'll be a positive 3 over 3, actually, plus b. Well, we know a positive 3 over 3 is just 1. So now we have that negative 1 is equal to positive 1 plus b. But we need to subtract that 1 from both sides. So we have a negative and a negative. So that will give us a negative 2 for b. So since b is equal to negative 2, we're going to just plug it back in here. So our answer is y equals negative x over 3 minus 2. And hopefully you can read that. Would be our equation of that parallel line. All right. I hope everybody out there understood and my bad handwriting tonight. But somebody said, let's take it a step further tonight. They said, what happens if it's perpendicular? Oh, that's a great question. What happens? So you're going to do the same steps that we did for the parallel, except when we have a perpendicular line, and I'm going to draw us a little perpendicular line on the side as an example of what perpendicular will be. I mean reciprocal. Yes, but you're missing something, somebody from Instagram. Not just the reciprocal. It's the what reciprocal? The negative. It is the negative reciprocal of the slope. So just like parallel, we use the slope from the equation that we have. So we're going to find this slope, but then we're going to use the negative reciprocal, and that will be the slope we use for our new line. So we are going to work through that together here. All right. And I'm going to be honest with you. I'm rusty. I haven't done this in a while. So this is a nice little challenge tonight. All right. So our first step, we want to know what is this slope, okay? So we are going to solve here. So we have a plus 5x will go to both sides. And we'll get 4y is equal to 5x minus 16. And then we're isolating that y. So we are dividing by 4 here. So we get y is equal to 5/4 x minus 4, okay? And we just said it's the negative reciprocal when you have a slope. So since it's positive, we already know our new slope is going to be negative. And what does reciprocal mean? What do? We tell our students all the time, it's just when you flip this. So instead of 5/4, now our slope for the line we're looking for is 4/5 x. And if that was a whole number, say 5, we know that all whole numbers have an imaginary 1. So when we flip it, it would become 1/5. All right, and now we continue with the steps we've been doing. So we're going to do y equals negative 4 over 5 plus x plus b. And we're going to now substitute in our 4 and our 5. And I'm going to make sure my camera gets back clear. I don't know why it fuzzed up a little bit. Hopefully you all can see. All right, so let's plug that in. We have 5 is equal to negative 4/5 x. Well, times 4 plus b. All right, so we know, like I said before, there's an imaginary 1. Give me one quick second, guys. I want to make this camera clean for you all. Okay, hopefully that's a little better. I don't know what happened. All right, so I had a 4 here, and so we're going to put it over 1 because any whole number has an imaginary 1, and that's important for fractions because we know fractions, you're just multiplying across from your numerators and your denominators, and sometimes we get a little scared when we don't see that one of them has a denominator, and it always does that imaginary 1. So 4 times 4 is 16. So we'll have a negative 16 over 5 plus b is equal to 5. And because we're not even going to do this, I'm going to use this extra room so we can see. So since it's a negative 16, we're going to add it to the other side. So we're going to have 5 plus 16 over 5 is equal to b. Okay. And then our regular fraction rules apply. We know that there is an imaginary 1 under here. So we need a common denominator so that we can add. So to get a common denominator, we need, we can really cross multiply, honestly. So we're multiplying by 5 here, and I mean, this is 1. So that's going to stay. And what we do to the bottom, we do to the top. So we have 25 over 5 plus 16 over 5. And so then we are going to add those together. So we are going to get a 1, and we're going to carry our 1, 3, 41 over 5 is equal to b. Okay? And so now we're going to come back to at the top, which was our original equation here. So we get that y is equal to negative 4/5 x plus 41 over 5. Well, that looks like a lot. That is absolutely correct in our y equals mx plus b form. But that was a lot. Somebody says, I like to write with those big Crayolas. Yeah, I sure do. I might have to switch it up because they're not being a good friend tonight with all this math in the little section. So this is how we do these same problems when they are perpendicular. So my question is, would you like to see one more with the perpendicular, or would you all like to move on? Does anybody in the chat have any questions they're looking for to be worked out tonight? Kimberly, we got anything in the chat? Okay. Well, if we do not, we are going to keep going here. All right, we're going to go ahead to elementary tonight. Now that we have done some big people math, we're going to go to some little people math. All righty. So we have comparing fractions here tonight, 4th grade standard. And around here, we love to use the butterfly method for comparing fractions, especially when they have different denominators. You can also use other models as well, but this is a strategy that we like and can be found in our strategy guide that we have, and it is called the butterfly method. And I'm going to show it to you all right here. So the way the butterfly method works is it helps us, just like we did in our last problem, actually, because our fractions, as you can see, it goes from our younger math all the way Yes, we know this is not educators' favorite method, but it does work. And it's just a strategy. You still need to know the basics, as you saw with the harder problem that we did tonight. So, really, your butterflying means you're multiplying the bottom and the top of the opposite numbers by each other. And theoretically, we know to get a common denominator, we're really multiplying the numbers straight across here. And it's the same steps, except for in a strategy form. So that is what we are going to do here with our comparison problems, especially since it's asking which statement is true. We can absolutely do this for multiple statements so that we can see what happens. So when we're butterflying, that means this will be a 3, this will be a 4. And I still like to show the denominators, so we're going to put a 12. And this is saying that 3/12 is greater than 4/12. Well, we know that is not correct. All right, and so we're going to keep that going. So then we have 2 times 3 here, which is 6. And we have 4 times 1, which is 4. And we know 4 times 3 is 12 again. So we have 6/12 is less than 4/12. Well, that's not true. All right. We have 2 times 3 is 6. 5 times 1 is 5. And we know 5 and 3 is 15. And I know some people do the method without finding the denominator still, but I just like to see it because I still want you to understand that we have made these fractions the same denominator so that we can compare. That's really the action that is happening. It's just we're doing it in a simpler form. And so now we have 6/15 is greater than 5/15. Hey, that looks right. And we can still check. Well, is 1/3 equal to 3/5? Well, the butterfly method still works here. So it'll be 5, it'll be 9, and 3 times 5 is 15. So does 5/15 equals 9/15? No, it does not. So that is a good method to solve comparing fractions. And it is something that still, while it might not be a fan of the educators, it's still theoretically doing the steps just in a modified way that you would do in the traditional form. And so I'm going to take one more from here just because it doesn't make you compare, but it does. So Pamela needs more than 2/3 cups of flour to bake a cake from her brother's birthday. Which of the following fractions is greater than 2/3? That's a great point that we got in the chat. That is so important to make sure you're checking all your answers because with some of the updates to state testing based on your state, a lot of the times they'll have 2 answers that are correct. It won't just be one. And we want to make sure that our students check everything so they don't get just partial credit when they were correct, but they get full credit because they got all of the answers correct. So thanks for sharing that in the chat. We appreciate that. So it says, which of the following fractions is greater than 2/3? So we're looking for something that's greater than, and you know what? We could just set up our own greater than sign and multiply these all by 2/3. And we're still keeping with our strategy from our strategy guide of our butterfly method. We multiply across on both sides and we multiply straight across. Well, we multiply diagonal is what I want to say. And then we multiply straight across to get our denominators. And then we compare, and we call that the fraction butterfly or the butterfly method. And for here, we can do the same with 2/3. Well, and if I'm a student, if I know my fractions and understand what they mean, I can already see 2/3 and 1/3. Well, that means we have 2 more shaded Well, we have one more shaded, or we have 2 of the 3 shaded, whereas we only have 1 of the 3 shaded. So I know it's not going to be 1/3. So using what we know to go ahead and eliminate, whereas maybe 6/9, you don't just see that as well, right? So you are going to have to do some work here. So 6 times 3 is 18. 9 times 2 is 18. And then when we do 9 times 3, that's 27. So we have 18 over 27 and 18 over 27. So those are actually equal. And we said we wanted greater than. So that still would not be our answer. All righty. So now we're going to do the same 2/3 here. And so we're going to get 12. We're going to get 10. And we multiply, so we get 15 and 15. So is 12/15 greater than 10/15? Actually, it is. And then if you did want to check your last one, because we want to be really sure, right? We're going to multiply. We get 3. We get 8. And we know our denominator is 12. And 3/12 is not greater than 8/12. So it would absolutely be B. Alrighty, I hope you liked that strategy, and we are going to move on to something else tonight. Please let us know if you have anything or you want to drop anything in the chat. It looks like everybody is working on fractions right now. So we are just talking about fractions tonight for sure. I actually want to do this one from a 3rd grader's problem. And I like it for a few ways. A lot of states are going to very open-ended questions because students, they want to make sure students know it, that they're not just using the answer choices to guess a right answer, but what do you really know? And a lot of people now, because in my day, I'm a little old, showing my age, we didn't really use these fraction tiles or this drawing at all. So I think even our parents, and a lot of the times we hear from our parents on social media, they don't know this new math or they don't understand. Making sure if you're tuning in tonight that you understand how to read this thing, right? So the bar up top, and that's one of the reasons I like this problem, that's our whole. So that one equals 1 whole. And whenever you see a line, so you see how this line connects with these lines, that means those are all equal to each other at that point. And that's anywhere. So how this line meets up with this line, that means this is equal to these two. So I'll show you what I'm talking about. So since we have 2 pieces, that means this is really 1/2 and 1/2. So those are those pieces. And then we have 3 pieces here. So that's a 1/3 and a 1/3. And we have 1, 2, 3, 4 pieces on this row. So that's 1/4 and 1/4 and 1/4 and 1/4. And then, of course, right, I think you've caught on. We're going to count again. 1, 2, 3, 4, 5, 6 pieces. So 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. All right. So we know if we have 1, 6 plus 1, 6, that's 2, 6. So this right here is telling us that that equals 1/3 because this is where the line stops here and there, they're the same. So 1/3 is equal to 2, 6. And that's how you can read this. And I'll also do the last row too. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8, 1/8. It's a lot of them. All righty. And so this is great if your student can draw it out or fill it in to answer any questions just like this, or to even compare fractions. So how in the last one we compared fractions using the butterfly method, this is a visual aid that you can use to compare fractions. So say that you had 4, 6, so that'd be 1, 2, 3, 4, and I wanted to compare it to 2/4, 1, 2. Well, which one's greater? Well, we know that 2/4 stopped here. So then our 4/6 is greater because it stops here. So it can absolutely be used. And so we're going to do our problem here. Which one is greater if we create a problem? So let's say 3/4, because I just added 3 of these, and that's there. And we're going to say it is greater than 1, 2, 3, 3, 6. And this is just a way for you to use these fraction tiles. And I just thought I would share because it's something that even I wasn't accustomed to using. And so we're going to keep it moving. And actually, they started using that in 3rd grade. And sometimes even before 3rd grade, just to get students acquainted with them as well. And actually, I'll show you another way how we can use that too. Let me see if you can see the whole equation. We were not doing fractions like that at all, okay? Old school way, all the way, okay? You learn those steps, and I don't know what you visualize. You better shade on your own. Better draw it on your paper. Okay, so this one here says decompose. So we want to make sure we understand what decompose means. That means to break apart, right? Decompose the fractions into units. Well, that same tile that we just drew, I'm going to bring it back. All right, so we have 2/4. Well, we could use our tile, and we see 2/4. Well, what can we break that down into? 1/4 and 1/4. It can help you decompose. And that's correct, right? Same denominator, 1 plus 1 equals 2/4, because we always know the goal is the same denominator to add our numerators. So you can absolutely even use those fraction tiles for decomposing numbers as well. So just something to share, because we know how much you love fractions out there. And so we've been working, that was 3rd grade and a little bit of 4th grade. So tonight we're going to go ahead and go to our 5th graders and see what they are working on. And since we just talked about this, I want to keep it going. As you see, it goes to 5th grade. So when you see this, just to give you some educator words, you took it right out of my mouth, scaffolding. So a lot of the times we see students, so we're actually a tutoring company, if you did not know, that they'll have gaps. And what we're encountering stuff that, as you saw, we had it in 3rd grade. You saw one part, right? Where we're just, how do you fill it out? We're comparing, we're seeing which one's larger, which one's equal. And now we get all the way up to 5th grade. And now look what they did to us. We don't have the same denominators anymore. We made it more complicated. Now we're subtracting. So it's scaffolding for us to get here. And that's how education is set up. So when we say sometimes we have gaps, we've missed a piece. So say you misunderstanding this chart in 3rd grade. Well, now it came up in 5th grade and you still don't know what to do. And so that's when we say, hey, we got to fill in those gaps, because all of this builds upon each other and it just gets a little incrementally harder each time. So now we're going to take those same strip diagrams and see, funny, this one, we have to know in our mind that a whole is 1, because they didn't even give us the whole on this one. They just went straight to the 1/2 bars, okay? So if you didn't realize that this equaled a whole, you were already out of luck tonight, okay? So we have 7/8 and 1/4. And so first I'm going to figure out, well, which one is my 8ths, which one is my 4ths? Well, we use it's by the rows. So 1, 2, 3, and 4. So I know this row is all of my 1/4. All right. And then I'm going to do another color, green. All right. And now we're going to find which one is our eights. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I made a great guess here. So 1 8, 2 8s, 3, 4, 5, 6, 7. So we have 7. And then I want to show you kind of what's visually happening here. So remember, we said if the lines equal together, that means they're the same. So what this is telling me is that 2 eighths is equal to this 1/4. So what we can do with that, we can say 7/8 minus 2 eighths, and that will equal 5 eighths. Woo! That was a lot simpler than finding the common denominator, wasn't it? Oh my God. You know, we used to have to do the old school way. What times 4 can give me 8, right? But now your student can visually see, if they can draw this drawing, that because these line up, these are already equal to each other. How else could we have done this same problem? Well, since I visually know that this 2 eighths and 1/4, well, we could go ahead and take that away, and then we could just count it 1, 2, 3, 4, 5, and knew that we have 5 eighths left. So it's actually 2 ways. And we always say in math, there's so many ways that you can do the same thing, right? Okay, so this is a great way to use a visual aid, especially when your students are struggling with understanding that those denominators need to be the same in order to do something with them. Okay, so this is a great way to get that started. So what do y'all think? Should we work another one? Ooh, it's getting real spicy. I'm liking these models tonight. I really am. All right, so this one is extra spicy. It says, find the sum of 5 6, 1/12, and 2/3. Woo! I'm getting hot. Thinking about this. So let's see here. So we have, I'm sure this is the 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So we have 1/12. Then we need a 2/3. So we have our thirds are up here. And we need 5 6. So 1 6, 1 6, 1 6, 1 6, 1 6. So 1, 2, 3, 4, 5 of those. All right, let's see how we can use this to our advantage here to help us solve this. So we know we have 2/3. And I'm just going to see what happens. As I can see here, I see that 2 6 is equal to 1/3. Because look, our lines match up. All right. And so we actually have 2/3. So we know that technically is equal to 1, 2, 3, 4 6. So we can say 5 6 plus 4 6. And so we'll already have 9 6 right there. All right, so that means we've already used this 2. And now we are adding this 1/12. Now, what can we do with that? That 1/12 is 2 of those 1 6. So 2/12 is equal to 1 6. So we get 10/6. And we are going to change this to this is an improper fraction. So we are going to take this from an improper fraction to a mixed number. So if we have 10 minus 6 will give us 4. So it can make a 1 whole come out of that. 1 and 4, 6. And you could reduce more, but we are going to leave that there. All right. Do we have any questions in the chat? Are they still with us tonight? Any more requests tonight? All right, if we have nothing in the chat, I have another one for us. Okay, I love it. Thank you for the hearts on Insta. We appreciate it for sure. Alrighty, so now we're going to our second grade babies. We get a lot of requests for helping second graders. In second grade, it seems like the work steps up a little bit, and it's such a great grade to make sure that you're getting the support that you need. Great question. Where can you find these worksheets? Kimberly might be able to share and drop our local school district that has these problems that you can practice with your students on. So Missy swam 287 feet yesterday and 378 feet today. How many feet did Missy swim in both days? And I'm sure people are like, oh, that's so simple. But this is a great time to start teaching your second graders some problem solving strategies. And I like this because especially when we really get into problem solving, that might be a little more challenging. It's a good diagram that supports us. So first we want to understand the pieces of this strip diagram. So your total is always at the top and your parts are always at the bottom. And so when you're solving a problem, you either have your total or you have your parts, right? And that's what makes an equation true, right? So maybe we have 2 plus 2 equals 4. So our parts are the 2 and the 2, and our total is the 4. And so we, for this equation or question, we'll have 287 and 378. So now that tells us we're missing our total, and that's what we're looking for. So we're just going to add those together. And this is great now in your students understanding the strip diagram, because when the future, when we have the total and we have one part, then we can start understanding that we're missing this part here. And so it's a great foundational skill to get them started on here. So then we're going to do our 287 plus our 378. And one of the biggest things, because I actually have a second grader right now, my son's 7, and we are working on 3-digit addition, funny enough. He always likes to start at the front. And it's like, why? But when you think about it, we read this direction, right? So that's why students think you should start here, because that's the way we read our numbers, correct? So I have him go ahead and label ones, tens, 100, or sometimes we also call this H2O, like water, and it helps our students remember hundreds, tens, and ones. And I always remind him we always start in our ones place. So we have 7 plus 8, which is 15. We're going to carry our 1. 8 plus 7 is 15. So plus 1 is 16. We're going to carry our 1 again. 2 plus 3 is 5, plus 1 is 6. Now, if you're not a carrier, a borrower, all of those old school words, that's fine. If y'all want to break this down into 200 plus 300 is equal to 500. And then doing 80 and 70, giving you 150 here, and adding that to your 500 to get 650. And then you doing your 7 plus your 8 to get 15, and then you still get 665. You are more than welcome to break that down by place value if you would like to. More than welcome. But the biggest thing that I really wanted to share here was knowing our total parts and parts using that strip diagram. I think it is great to start it in second grade, because we know when we start heading to those testing grades of third and above, these are the strategies and skills that really set students apart and really make problem solving so much easier for them in the future. All righty, Kimberly, are we taking one more? Do we have anything in the chat? Or are we calling it a night tonight? I'm going to let Kimberly decide. Last call. Last call. Okay, somebody's coming. Oh, yes, yes, yes. Oh, and we would love to connect with you. We love the homeschool community and want to connect more with the community. So please come, bring your fellow friends. DM us. We would love to chat with you for sure. What grade is your homeschooler in? I've not done percentages yet. Would you like percentages? And if so that's a request. What about percentages? What are you looking for percentages? I don't have anything submitted, but what do we need for percentages? Tell me more. Tell me more. Kinder in 6th grade. Okay. So you're you're on two ends of the spectrum for sure in your homeschooling journey. But that's great. That's great. Did my percentages person say any more about what they're looking for percentages? Simplicity to explain. Okay. The only thing I'm unsure is like what kind of problem to share. Or are you meaning more? Could you share like a quick example? Is it just like more of like what a percentage is, or taking percent of a number, or I'm just not sure And I want to make sure that I'm giving you what you're looking for. And let me get out some paper. We are here every Wednesday at 7 p.m. to 8 p.m. Sometimes I'm a little late, like today I dropped water, so it was 7:10, but we are always coming. And you can submit your problems ahead of time to help at Math-A-Matics tutoring.com. And so how you've even asked tonight about percentages, if you just send me an example, because I just want to make sure I answer the kinds of problems you're looking for. Because like I just said, I can think of 5 different ways and different grade levels that percentages are introduced. So I just need a little bit more. What grade level are you looking for percentages? Is it percent of a number? Is it using percent for proportion? Things like that. That's all I'm looking for. Yes, quick tips. Let's do one taking a percent of a number. Perfect. Sounds good. Okay. Let's do it. All right. So, one thing we know, and I'm just going to make up some numbers. 45. And we want to take, I'm going to torture myself tonight, 9%. All right. So when we're taking whenever we have a percentage, what that's really saying is 9 over 100. Okay. So we are really doing 9 over 100. All right. And so we have our 45 that we are taking here. And so we can turn this into a decimal from our 9 over 100. And since a fast way to change this into a decimal, we have 2 zeros. So technically, this is one thing about numbers, there's a lot of imaginary things going on. So technically, it's like an imaginary decimal behind your 9, and you're going to move it 2 times because you have 2 zeros here for that 100. So we're going to move it 1, 2, and I'll just show it to you like this so you can see it. So that's really 0.09, and let me move that paper up. And so then what we could do from here, we can multiply that times our 45. And then we will just use our same multiplying by decimals rules that you do in elementary, right? So I tell my students, how many places do we have behind the decimal? 1, 2. So I use the term DP, meaning decimal places, because it lets me know how many times I'm going to need to move that decimal after we solve this problem. So it's kind of like I pretend that that's gone, really. And then so here we're going to multiply. So 9 times 5 is 45. 9 times 4 is 36, and 36 plus 4 is 40. And then we know this is just going to be zeros. 0, 0, 0. Because we have a 0 placeholder because we're in the tens place. And then 5 times 0, 0, 4 times 0, 0. We add that. We get 405. And then we had to move 2 DP or 2 decimal places. 1, 2. So it is 4.05. So 9% of 45 is 4 5/100. How would I teach a kinder the concept of addition and subtraction? I would use things, visuals. So let's get some goldfish. Where's some pennies? Where's some bears? Like pretending it's I'm giving you, I'm taking away, letting them count it, and just really using a lot of visual aids to start, and then using those side by side of maybe a whiteboard. And then now you show, okay, if we have 6 goldfish here and we have 5 goldfish and we write those numbers, this is how we add and how they come together. So, how do you count out how many you have total? How would I subtract if I told you give mommy 2 goldfish or give daddy 2 goldfish from the 6 goldfish you have? For kinder, I would really start with visuals. I think you're right on track. Honestly, games are great. Kids learn the best when they're really like engaging and doing. For sure, especially our younger babies. Because you don't get their attention for as long, it's great to have stuff that they truly engage in. And really, it's the touch for them that I think works very well. And then doing slowly, like the paper with them. I know even my son, when he was in kindergarten, I felt like we did a lot of like pictures for addition and things like that. And then first grade, he was adding really fine. So I think honestly, you're on the right track. Yes, counters are really great too. Hmm. Anybody else? All righty. You know, just keep showing them math. We get so many students who are afraid of math. They have to have the aha that they can do it. I'm not sure if it's your kindergartner that's afraid, or if it's one of your older, or if you had an older student that's afraid of it. It's figuring out where they kind of like lost the love or what they're not understanding. Because once they feel empowered, like, oh, I can do this. Oh, I can get this. Starting them off with something easy, then letting them know that they could do something harder. And then one saying that we say here a lot in our tutoring, and I say it to my own son: you can do hard things. And learning happens when we make mistakes. I think one thing that a lot of people get caught up in math is when we're like, oh, your answer's wrong, right? And we say it like that. It brings that fear on, when instead it should be like, you didn't get this answer correct, but guess what? We can learn from this. And it's how you approach it, which helps create that scaredness or that fear of getting the answer incorrect, but letting them know, hey, you got that wrong, but let's go back through that. Let's work it. Let's see where your mistake is. And I actually believe in this, that you learn more when you make mistakes. You learn more when you get it wrong, because you got to go back and figure out what happened. And I think a lot of the times where students get lost, nobody goes back with them. Nobody goes over the problem and sees, where did you make those blunders that we won't make again. And when somebody points them out to you, then usually you're more cognizant to say, oh, I did that last time, so I'm not going to do it again. I feel like I'm just preaching tonight. Oh, goodness. So, Eastern time, no, it would be 8 Eastern, because we're Central time. So, we're 7 p.m. Central. Oh, you're West Coast. It's only 6 p.m. here. Okay. So good to know. Thanks for joining us. So we might need to start putting some slashes on our time zones too. for our East and West Coast people as well. But we are 7 p.m. Central Time here. Are you raising your hand, Kim? You got something for me? Take us to church. You cutting up. Well, thank you all for joining us tonight. We are here every Wednesday, like we said. We are a tutoring company. We would love to see more people's problems, questions you have. We've been doing this for over 13 years, and we're truly passionate about sharing our love for math and making kids not feel scared about math and feeling more empowered to do math, because it really can truly unlock so many things. I see all the time on threads, people like, I don't even use this, I don't use that. But it does unlock a new level of careers. And especially as we are getting more AI and tech savvy and things, the problem solving skills that you learn as you progress in math are unmatched. And they are skills that you want your child to have because they are so transferable in just the everyday things that you will do. Thank you for joining us, and we will see you next Wednesday. Follow us on Instagram. Watch our videos. We make videos too. DM us a request. I forgot about that. And we will make a video of whatever you're looking for. Have a great rest of your night. Bye-bye.